अब लेट्स कम टू ब्लैक होल। ब्लैक होल पे भी क्वेश्चंस आए हैं एग्जाम में, नॉट डायरेक्टली ऑन ब्लैक होल बट वेरियस टर्म्स एसोसिएटेड विद ब्लैक होल। लेट्स कंसिडर अर्थ। Let's consider Earth. When we are 10 meters above Earth, Earth pulls us towards itself. The force that is applied on us is basically G m by r square. R is the distance from the center that we have, where we are. है ना? Suppose same mass was, ये मास अर्थ का था, सपोज द सेम मास वाज कंप्रेस्ड इन दिस, सेम मास वाज कंप्रेस्ड इन दिस साइज, और आप इससे 10 मीटर ऊपर रहते, will r would have been lesser? m and m would have been same, but r would have been lesser. Force applied, gravitational force applied would have been much higher. Compress it further. Will gravitational force be further higher? और compress कर दो, gravitational force और drastically बढ़ेगा. As r is reducing, r radius में squared में है. Will gravitational force keep on increasing? If you keep on shrinking it, gravitational force will keep on increasing. So basically, a time would come when gravitational force is so high. A gravitational force is so high that it will not allow anything to come out of it. Even जैसे Earth से when you emit light, right now when you send light wave outside, is light able to go out? है ना, आप यहाँ से light emit कर रहे हो, light is able to go to other planet also. या दूसरे planet से light is able to come here. दूसरे star से light, can you see other stars? You are in the gravitational field of sun, but can you see other stars? It means उन stars से light is able to come here. That is how you will be able to see. But suppose those stars eventually were compressed so much that the force was so high that even light particles are not allowed to come out. Let's say this was a star जिसको हमने इतने छोटे में compress कर दिया. Or forget star. Let's think of a mountain. Mountain का एक mass होता है m. What is the gravitational force that this m will apply on you? Gmm by r square based on your distance. आप m same रख के अगर r बहुत छोटा, like इसका size बहुत छोटा कर दोगे, is there a chance that it may become a black hole? A mountain may become a black hole? Yes, it's possible. If एक बहुत बड़े mountain का mass आप एक atom के size में compress कर, so its m will remain like this, but r will become so less that force is equal to g m by r square. R will become so less that gravitational force would be so high that it will not even allow light to come out of it. It will not even allow light to come out of it. This is what? Black hole. Why black hole? Why am I able to see something? When I look at this person, I'm able to see this person because some light is falling on him and then it's coming to my eyes. I'm able to look at a star because some light from that star is reaching my eyes. Some electromagnetic wave from that star is reaching my eyes. But if there's a body, उसपे कोई भी light पड़ती है, कोई भी light जाती है, it is not allowing it to come out. Will I be able to see it? This is black hole. This is black hole. I hope you understand the meaning of black hole. So black hole will be a place in space which will not allow even light to come out of it. Now, एक और बात समझते हैं. देखो, suppose this is the black hole. This is the black hole. This is the size of black hole. So can black hole be of very small size? Yes. Can black hole be very large sized? Yes. Large size की भी हो सकते हैं. Mass इतना ज़्यादा है. Even in large radius, they are black hole. G mm by r square. अब आप m बहुत बड़ा कर दो या फिर आर बहुत छोटा कर दो, या फिर दोनों कर दो, m is also very high, r is very less. Eventually you can reach a force level where even a photon is not allowed to come out. Did we understand? यहां पे light पड़ेगा and light will just go in a one way. But please tell me, the force here and the force here, which force will be higher? If this is black hole, F1 will be higher है ना, F2 कम होगा. तो ब्लैक होल के अराउंड इवेंचुअली देयर विल बी अ प्लेस जहां पे फोर्स इज लेसर एंड लाइट कैन गो आउट ऑफ इट. सपोज यहां पे खड़े होके यू आर एमिटिंग सम लाइट, यहां फोर्स इज लेसर एंड लाइट कैन गो आउट. तो ब्लैक होल डजंट मीन दैट हर चीज उसमें घुसी जा रही है, ओनली टिल इवेंट होराइजन. इवेंट होराइजन इज दैट बाउंड्री. ब्लैक होल की इवेंट होराइजन इज दैट बाउंड्री जहां पे nothing can come out. But if you are outside event horizon, if you are far away from you or away from your event horizon, then gravitational force would be lesser and light will be able to come out and so on. Right? If a planet is here, that planet is gone. Black hole में गया. It's not coming out. But let's say this is my event horizon. Let's say this is my event horizon, the boundary. Can a planet revolve around this? ये तो gravity का source ही है ना. Can a planet revolve around it? It can keep revolving around it. Just we should be more than under root gm by r. We should be equal to or more than under root gm by r, else it will fall on it. So when we think of black hole, do not assume that black hole है वो सब कुछ अपने अंदर खींचे जा रहा है. Anything which enters event horizon is going in. Anything which is going in is not coming out. That is black hole. Are we able to understand what black hole is? Pakka? So, black hole is a place in the space where gravity pulls so much that even light can't get out. This strong gravity is because matter has been squeezed into a very tiny space. This can happen when a star is dying. अभी हम आते हैं कि कैसे some stars will eventually become black hole. This can happen when star is dying. It doesn't mean that सिर्फ इसी तरह से black hole बने. There are other black holes. Now, since no light is emitted from them, they are invisible. You will never be able to see a black hole. But sometimes you see pictures depicting black hole. How do those pictures come? अभी समझते हैं उसे. Those are not light coming from within the black hole. Those are because of activities happening outside. जैसे suppose this is a black hole का event horizon and there are some planets which are revolving around it. है ना? उसका if this planet का some mass is breaking, it will be falling into the black hole. Before event horizon, some of it may burn. और उससे जो light emit हो रहा है, we may be able to see that. Once it enters event horizon, even light will not be able to come out. But before it enters event horizon, before this mass enters event horizon, it may burn up, it may oscillate, it may produce electromagnetic radiation. And will we be able to see that electromagnetic radiation? That is how we are able to see the presence of black hole. Not by seeing the black hole, but its gravitational impact. Got it? So, a black hole is a place. ये हमने समझ लिया. They're generally detected by telescopes by analyzing the behavior of stars that are very close to black hole. A star can be a planet for black hole. A star can be a satellite for black hole. A star may be revolving around a black hole. Now, how large can black hole be? The black hole can be as small as an atom and it can be very large as well. जैसे मैंने आपको बोला था कि एक माउंटेन का मास, you compress it in size of a atom. R will become so less that within its event horizon, if anything goes, it will not be able to come out. So black hole can be very small. It is said that within our solar system also there may be some black hole. हमने कल exoplanet पढ़ा था. What was exoplanet? Planets outside our solar system. Now, recently, 3-4 years back in news, a planet 9 was being discussed. Our solar system has 8 planets. So, scientists were saying that there's a planet 9 also somewhere, but it's pretty large, and such large planet, such far away from sun, may not be possible. It must have come from some other solar system, and that is why they were discussing it from the perspective of exoplanet. They were saying that this planet 9 is a exoplanet. We haven't discovered the planet 9, but some behavioral aspects of other objects around it are indicating that a large mass is present there. We haven't seen that, but it's present. तो planet 9 को हम exoplanet बोल रहे थे, क्यों? Because Earth may have, Sun may have got it from some other planet. It must not have originated from Sun. इसलिए planet 9 को हम exoplanet बोल रहे थे. But then some scientists said, no, it may not be exoplanet. It may be a black hole there. It may be a black hole there which we are not able to see, but its gravitational influence is there, and it is because of its gravitational influence that material around it are behaving in a particular way. They are looking for a planet, but it may actually be a black hole. So I say within solar systems also black hole may exist. Are we understanding this? Black holes can be very small. Black holes can be of different sizes. 1 atom के size का हो सकता है, तो क्या 2 atom के size का भी हो सकता है? 1000 atom size का भी हो सकता है. So black hole can be of any sizes for that matter. Okay. Stellar is a type of black hole whose mass is around 20 times mass of Sun. There are many stellar black holes in our Milky Way galaxy. Every galaxy will have many of such large black holes, stellar black holes. But then there are supermassive black holes. Supermassive black holes are the largest black holes, and ये generally कहाँ मिलते हैं? ये मिलते हैं galaxies के center पे. These black holes have masses that are more than 1 million suns together. Every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of Milky Way galaxy is called Sagittarius or Sagittarius. ये शायद टेस्ट में आ गया था, है ना? It has a mass of 4 million suns. मैंने कल आपको बोला था ब्लैक होल पढ़ा लेने दो, आपने पढ़ाने नहीं दिया. So it has mass of 4 million suns and would fit inside a very large ball that could hold a few million. तो उसका size is of a few million Earth, but mass is of 4 million suns. So it has a very large mass. That is the black hole which is there at the center of our Milky Way galaxy. So black holes में देखो, there may be stellars, large black holes, but not supermassive one. But there can be supermassive and there can be very small black holes also. एक और term जो बार-बार आप न्यूज़ में सुनोगे, which prelims में पूछा जा सकता है, that is quasar. Now, what are quasars? Quasars are active these black holes, these supermassive black holes, which are located at the center of galaxies. These are known as galactic nuclei. बात समझ में आई? These black holes, these supermassive black holes, which are located at the center of the galaxies. कल हमने मिल्की वे गैलेक्सी का एक छोटा सा इमेज देखा था. We saw our solar system was present somewhere on the outskirts of it. So Milky Way galaxy ke at the center, what do we have? A black hole. That is called galactic nuclei. So quasars are a subclass of active galactic nuclei, extremely luminous galactic cores where gas and dust falling into a supermassive black hole emit electromagnetic radiation across the entire electromagnetic spectrum. They are among the brightest objects in the universe. So देखो ये ना, they are showing you an image of a galaxy. Galaxy के बीच में क्या है? Black hole. Black hole will be galactic nuclei. Black hole will be galactic nuclei. Now in this galactic nuclei, a lot of mass will be falling. While a lot of mass is, once that mass crosses event horizon, nothing will come out of it. But when it has not crossed event horizon, it is just falling. Because of various factors, acceleration, etc., a lot of radiation will be emitted. A lot of radiation will be emitted, right? You can see this emission occurring here. इसे हम क्या बोल रहे हैं? Quasars are subclass of active. In some active galactic nuclei, in some of the black holes at the center of galaxies. Extremely luminous galactic cores where gas and dust fall into a supermassive black hole, emit electromagnetic radiation. So some of these are very luminous, some of these are very bright, not because of the black hole, but the radiation which are getting emitted. Those are known as quasars. तो यूनिवर्स में सबसे बड़े एक्सप्लोजन्स में हमने एक टर्म पढ़ा था सुपरनोवा. These are among the biggest explosion in the universe. ऐसी it is one of the brightest things. Quasars are among the brightest things in the universe that we'll see. Okay, तो यहाँ पे these are among the brightest objects in the universe. Now, black hole in itself is dark, but black hole में इतना material एक साथ जा रहा है, it is emitting a lot of radiation, which is brightening up that surrounding of that galactic nuclei. Those are known as quasars, and this is not happening in every galactic nuclei. जिसमें हो रहा है उसको हम क्वाजर बोल रहे हैं. तो इसीलिए क्वाजर्स आर अ सब क्लास ऑफ एक्टिव गैलेक्टिक न्यूक्लियाई. क्वाजर्स आर नॉट all the active galactic nuclei will not be forming quasars. Are we getting it? Okay. देखो, all quasars are active galactic nuclei, but not all active galactic nuclei are quasars. The boundary of black hole is called event horizon. ये मैंने आपको बता ही दिया. Event horizon is the place. उसके बाद what happens? What comes into play? No light is coming out. That system comes into play. Okay. यहां तक चीजें समझ में आई है. ब्लैक होल क्या है? नाउ सम ऑफ द स्टार्स. हमारे पास न्यूट्रॉन स्टार्स थे. डू यू रिमेंबर न्यूट्रॉन स्टार्स? वी हैड सेड दैट द हाईएस्ट पॉसिबल मास ऑफ अ न्यूट्रॉन स्टार इज 3 सोलर मास. उससे ज्यादा मास का न्यूट्रॉन स्टार होगा, what would happen? Gravitational force will be high and further compaction. Gravity will pull everything together. यहां पे न्यूट्रॉन का जो डीजेनरेसी प्रेशर है, that will not be able to prevent this compaction from occurring. And these things, these neutron stars will eventually become what? Black holes. Because उसमें तो फिर compression होता ही रहेगा ना, होता ही रहेगा, होता ही रहेगा, होता ही रहेगा. It will keep getting smaller, keep getting smaller, keep getting smaller. Eventually, R will become so less. Mass, so we understand, but R will become so less that what happens? It goes into a scenario of black hole. So some stars were becoming what? Some stars were becoming dwarf, eventually black dwarf. Some stars, neutron stars, and neutron stars which are more than 3 times the size of sun, they become black hole. Right? तो एक सन का लाइफ, एक स्टार का लाइफ, अपने सन का लाइफ तो इज गोइंग टू बी ब्लैक ड्वार्फ. But some bigger stars will become black holes. Right? Are we comfortable here? Okay. Now, singularity and event horizon वाला फंडा थोड़ा सा जानते हैं. Singularities, black hole. The event horizon we have understood. What is event horizon? वो point beyond which, वो boundary beyond which what happens? Even light is not able to come out. We can say कि it is the boundary of black hole. Right? Now, कोई एक black hole है. Is its gravitational force impacting me? अभी let's say there's a black hole at the center of our galaxy. We are located somewhere far away here in this solar system. In this solar system, we are located on Earth. Earth पे भी एक particular point पे मैं खड़ा हूँ. Does the gravity here have any impact on me? Yes, आप बोलो हाँ है. It has an impact. Gmm by r square. R is so less that you are not getting affected by it much. Sorry, R is so large that force is so less that you are not getting affected by it. But gravitational force तो रहेगा ही. तो ब्लैक होल का ग्रेविटेशनल फोर्स बाकी जगहों पे भी है. इट्स ओनली विद इन इवेंट होराइजन व्हाट हैपेंस? इट इज सो हाई दैट इवन लाइट इज नॉट एबल टू कम आउट. ओके, अब देखो हमने एक और चीज पढ़ी थी. among the densest objects in the world. We said black dwarf or white dwarf or among the densest object, but उनसे भी ज्यादा dense क्या होता है? न्यूट्रॉन स्टार्स. अब न्यूट्रॉन स्टार को भी और कंप्रेस करके आप ब्लैक होल बना रहे हो. तो ब्लैक होल्स विल आल्सो बी थिंग्स ऑफ वेरी हाई डेंसिटी. बट एक और चीज आपको याद हो, हमने नोट करी थी, इन केस ऑफ न्यूट्रॉन स्टार्स it had solid surface, whereas in case of black hole we are not saying that. Why? Because of singularity. So in 1915 the scientist Carl Schwarzschild noticed that Einstein's then new general theory of relativity predicted existence of an object or strange object known as singularities. So what is singularity? Black hole में हम बोलते हैं black hole के अंदर क्या होगी? Singularity. They were places where his new equation describing gravity seemed to go haywire. Inside them, there was a bizarre place where time stopped, space became infinite. Over the years, evidence have piled up explaining that singularities do exist. And where do they exist? They exist in our black holes. So within black hole, अब ना इसे समझा पाना थोड़ा चैलेंजिंग है. इसे बस ऐसे इमेजिन करो कि within black hole, time doesn't change. Time has stopped. Within black hole, space has become infinite. अब इसके implications क्या है? I do not want to go into all that. आपने इसके implications बहुत सारी scenarios में देखे होंगे. In various movies, आपको someone getting into singularity and how it is impacting things, है ना? इंटरस्टेलर में वो सब है, बट उसे हम समझा नहीं सकता मैं. बट एग्जाम में सवाल आएगा सिंगुलैरिटी अ टर्म है, वो किससे एसोसिएटेड है? वो ब्लैक होल से एसोसिएटेड है. सिंगुलैरिटी वाज आइडेंटिफाइड वे बैक इन 1915 where it was understood कि theoretically there are places where this equation of gravity etc would not work. So in reality have we been able to find those places? So yes, those places are ब्लैक होल. अब देखो ब्लैक होल के अंदर क्या हो रहा है ना, theoretically we can make theories and rules, but अंदर क्या हो रहा है, will we ever be able to observe it? At least for now we will not be able to observe it because nothing is coming out of it. एक्स रेज, गामा रेज, कुछ तो निकल रहा होता ना, जिसे हम देखते और बोलते कि भाई this is what's happening inside it. So inside black hole what is there? What is the state? That is a state of singularity. ओके, तो एग्जाम में पूछा जाएगा सिंगुलैरिटी किससे एसोसिएटेड है? ब्लैक होल से एसोसिएटेड है, स्पेस से एसोसिएटेड है, उस तरह वो आप आंसर कर पाना. ओके, नाउ स्पॉटिंग अ ब्लैक होल. ये स्पॉटिंग अ ब्लैक होल मैंने आपको समझा दिया है कि देखो ब्लैक होल वैसे तो हाउ विल वी सी अ ब्लैक होल? देन ब्लैक होल विल बी सीन बाय if the unseen companion happens. So around black holes what happens? There may be some companion star, there may be some other planet revolving around black hole and so on. So if the unseen companion happens to be so यहाँ पे हम बोल रहे हैं black hole is identified by the gravitational force it exerts on nearby stars. So if you see a star and that star is revolving around some nothing, that may be what? That may be a black hole. It may be a black dwarf also, but that may be a black hole too. So if the unseen companion happens to be a black hole, then because of its high gravity, it will start pulling matters of the surface of the visible star. So from visible star, a lot of matter will fall into black hole. And when it is doing it, this matter starts falling towards the black hole in a characteristic spiral path. In this process, it also emits X-rays. And X-rays emitted before reaching singularity, we'll be able to see that. That is how we identify and study black hole. Okay, तो अब ब्लैक होल्स को बहुत इंट्यूटिवली समझना थोड़ा मुश्किल है, बट जितना बेसिक लेवल पे मैं समझा सकता था दैट इज